Hi guys, today I'm going to be talking about number 15 on the chapter 4 homework. So basically there's a ball thrown off of a window on a building. So in my diagram, this right here would be the building and h is the height. And so this would be the point from which it is thrown off of, and it says it's 20 degrees below the horizontal, which I labeled, and with an initial velocity of 8 meters per second. So I labeled x as the horizontal distance it would have traveled, and the problem also gives us time, so t equals 3 seconds. So for A, we're looking for the horizontal distance that it traveled. And the equation I would use is x equals v initial t plus 1/2 at squared. But since there is no acceleration in the x direction, we don't really need to think about that at all. So I just used x equals v initial t. So we just plug in what we were given, velocity. So velocity is 8 meters per second. And since it is thrown at an angle, we need to multiply that by cosine of 20, and we multiply that by the time, which is 3 seconds, and that yields 22.55 meters. Alright, so for B, we're basically looking for the distance it traveled in the y direction, or the height of the building. And so we would use the same equation, except now we do have to take account of the acceleration, which is gravity. So since it is in the y direction, instead of cosine, as we used earlier, we'll use sine of 20, but we just plug it in again. So 8 meters per second times sine 20 times 3 seconds plus half of 9.8 meters per second squared, which is the acceleration of gravity, and times 3 seconds squared. Since gravity and the velocity are going in the same direction, we don't need to subtract for the second part of the equation. We'll just add since they're going in the same direction. And you just plug that into your calculator and you get 52.39 meters. Alright, so for the last part, we're looking for the time that it takes for the ball to drop 10 meters from the start point. And for this, since we're only focusing on the y direction, we use a similar equation as above. But since we know the distance traveled this time, t will be the variable. So height equals 8 meters per second times sine 20 times t plus half of 9.8 meters per second squared times t squared. And we can set that equal to 10 meters, which is the distance traveled in the y direction. And you just plug that into your calculator. Hopefully you have a program, and you get t equals 1.18 seconds.